Hey everybody, so in this video I'm going to show you what the mean value theorem is. I'm also going to show you an example of it. So all you have to remember is these two requirements and then this last one right here. So for the mean value theorem to apply in any equation, any function, we need f to be continuous on the closed interval, and then f has to be differentiable on the open interval. And if those two requirements are accepted or are present, then the derivative of that function, you set it equal to this, which is kind of the way to find the slope. So you set the derivative equal to f of b minus f of a over b minus a. Just remember that right here. I'm just going to show you right now an example of the mean value theorem. So right here we're given f of x is equal to sine of x, and the interval we have is 0, pi, closed interval. So we're going to start by testing these requirements, see if it applies here. So is f continuous on the closed interval? Yeah, because the graph of sine, if you take a look at it, it's just continuous. There is no stops, no asymptotes, no gaps. It's just continuous. So this applies. And is f differentiable on the open interval a, b? Let's see. The derivative of sine of x is just cosine of x, and it is differentiable, yeah. There's no problem there. And then now all I have to do is set the derivative equal to this right here, f of b minus f of a over b minus a. All right, so that f of b minus f of a, let's begin. F of, what's b? See, a comma b. B is pi, f pi minus f of 0 over pi minus 0, b or b minus a, pi minus 0. Okay, f of pi, sine of pi, if you look at the unit circle, where's pi? Pi is right here. What's the sign over there? 0. So that is 0 minus, what's f of 0? Sine of 0, that's another 0 right there. Okay, and then pi minus 0 is pi. Therefore, we have 0 over pi, and that is just 0. So, again, we're going back right here. What do we have to do? We already found this whole mess right here. We found it. It's equal to 0. And then we set the derivative equal to what we got here. So the derivative, we did it before right here, is cosine of x. So we set that, cosine of x, as we said before, equal to what we got from this. And we got 0. 0 over pi is 0. Okay, now solve for x. The cosine of x is equal to 0. That means at what angle would our cosine be 0? Given this interval right here, because you could have more than one. So the interval 0, pi only spans on the first two quadrants. So where in these first two quadrants do we have cosine equal to 0? That is right here at the angle pi over 2, where the coordinates are 0, 1. Now you might be tempted also to add the 3 pi over 2, which also has cosine as 0, because right here we have 0, negative 1. Cosine is 0 here. But because the interval only restricts us to the first two quadrants, between 0 and pi, from here to here, that means our only cosine of 0 is at the angle pi, 2. So our answer is, pi over 2. Did I say pi, 2? So our answer is pi over 2. That's it. That's our answer.